Hey everybody, this is Larry. This is day 30th, right? of the Leetcode daily challenge, October. I don't know what's going on. I took a lot of naps today. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. And apparently you can cheat directly now with AI. But in any case, yeah. Today we have a hard problem, and before I start, let's go over my. I mean, you could skip ahead if you want, of course, because we do have the technology. I believe in you. You don't have to complain. But today's my rest day, even on the tapering week where I'm doing a little bit less work. But I just want to go over a little bit of my brain, my thought process, what I'm thinking about, because I think you watch this channel. Actually, I mean, I don't know. There are a lot of reasons people watch this channel. Maybe sometimes to get the problem. But for me, it's just maybe some part of it's for me. I don't know. Let me know in the comments. But what I wanted to say is that hopefully this doesn't come up as a humble brag, but I consider myself fairly good at Leetcode and fairly good at competitive programming. Better in the past for sure. When I was trying, I haven't really. I mean, every quote unquote practice that you see is, or every practice that I do, quote unquote, is what you see on this channel. Basically, I don't do any. I mean, I do programming outside of it, but I don't do any algorithm or this kind of programming. And honestly, with LLM, I don't even do as much programming as I do outside of this, because like if I'm writing a small script, I just do it. I know what I want. I just don't type it, right? So I just ask LLM to do it, and then quad code, and then it messes it up, and I'm like, no, do it this way, and then it messes up again, and no, do it this way. And eventually, it gets it right. So I don't know if it saves me time, but that's what happens. But anyway, one thing that I do want to talk about, though, as someone who is quote unquote good, is kind of just want to share my struggles here with, because I think a lot of people, when they you're doing this because you have an interview coming up, or maybe you're preparing for an interview that might come up, right? And in a way, that's what I'm basically. That's the situation I find myself in right now with the marathon. The marathon's on Sunday, and I am honestly at this point as ready as I'll be, right? In the sense that if I run really hard today, it's not going to show up on Sunday. My body just don't adapt that quickly, right? And so I'm as ready as I'm gonna be, and I do not feel ready at all, to be frank. But you already put in all the work, you already followed the plans, you already did all you can. So whether you feel ready or not, it doesn't matter, right? So what I'm trying to do now, the last couple of days, is just sleep as much as I can, rest as much as I can, eat as much as I can, and make sure that when I am ready, and I run a little bit just to make sure I'm not sluggish. So maybe the Leetcode code area would be just do like a couple of easier mediums, nothing that would stress yourself out, but just just to be like, okay, I remember how my fingers work or something. I don't know, right? So yeah, I think and even I'm not gonna lie, like it is definitely still a mental struggle for me at this point, because I get it, right? Like I spent the last 4 months, and maybe you also spend the last 4 months watching me complaining about it, or maybe just talking about it. I don't complain all the time. But I do complain about being tired, I suppose, the last 4 or 5 months, and it all kind of just come to this one event, one thing, right? But let me give you some numbers. In the last 4 or 5 months, I ran about 600 miles, 250 miles last month, 250 this month, so like more than that. I gotta actually do the math, so I'm lazy. 800 miles the last 3-4 months, right? And you know what? I put in all that work. And I am much fitter, right? Much more fit. Whether I hit my goal or not on Sunday, that 26 mile is just the end, and it may not even be the end, right? Like I think one thing that I see sometimes is that people always make these things as like almost like a do or die. But look, also honestly, I'm signed up for next year. So like, you know, if things don't go well, there will be next year. It's a long time. I'm getting old. I don't know if I want to train that hard again, but if it's what I want, then it's what I want, right? Um, yeah, I think that's basically the thing, because I think it is kind of amusing that, like, there's this like grind mindset, or do the kids call it Sigma mindset or something, right? Grind set, I don't know, whatever. Um, and I'm just thinking for my history, my past, right? Like, I've, just to be clear, like, definitely messed up interviews. I definitely, like, not always, not necessarily on the coding part, but sometimes the coding part, but even on, like, I don't know, behavioral, just like talking about the wrong things or something like that. And I don't know. I mean, it's tough. I mean, there is a huge survivor bias, so that's my disclaimer, right? Because if I did not survive, I would not be here, and you would not be listening to me. But I also feel like, you know, like the failures and the struggles that I did in my career, like, they made me better both as someone, as a software engineer, and also just a person in general. Hopefully, I don't know. Maybe some people might disagree, but um. So yeah, so that's what I would say. So these things, I don't know. They are important. You should treat them as important, but they're also not necessarily life changing. Um, the failures are only there for you to climb over, right? The success, they will be life changing, right? There are definitely a lot of things where you are successful, or I was successful, and it changed my life. But the failures, it would only be life changing if you let it stop you from getting that successful, life changing yourself. So I don't know. All right, that's basically my intro talk for today. So let's take a look at today's problem. We have a hard problem today. Let's go. We have 1526 minimum number of increments on subarray to form a target array. You're given an integer array target, integer array initial of the same size as target with or for element. Oh, initial. Okay. Sorry, I kind of peeked ahead and I got confused. But it's okay. So we have all zeros. We have a target. Okay. In one operation, you can choose any subarray and increment each subarray by 1. Return the minimum. Okay. So here you just do almost like a Primit style. So the first thing I want to do is look at n, right? It matters whether we can do n square or n log n or what, or O of n maybe even. So I just take a look, and n is 10 to the 5th, meaning that okay, it's clearly not n square. Target sub I is equal to 10 5 is maybe interesting, because there is some nuance between 10 to the 5th and 10 to the 9th, in which maybe there's some difference. I don't know actually if it is that different, because maybe you could normalize it, or whatchamacall it, coordinates compression. But we don't even have to think about it necessarily. So we'll see. Okay. I think. Oh yeah. I think the first thing, and I didn't make it explicit, but the first thing that came to my mind is, instead of starting from initial and going from initial to target, it's a symmetric problem, right? Meaning that this is a problem in which if you do things backwards, you're able to do it backwards. It's still the same result. So, and what that means is that going from target back to all zeros, but decrementing instead, right? Okay, so that's kind of, because that may be easier to do, maybe not, but that I don't know, that maybe that's an intuition thing, and that may also be a visualization thing, right? Like as a visualization tool, so that may differ, right? Depending on how you think about it. But okay. I think the first thing I want to think about, right, is like it is going to be some sort of segments. And I think there are more. But you're always bounded by the minimum, and then it is becoming like then you have to segment them, right? Separate them, divide them, right? So I'm gonna bring up the drawing thing so that I can kind of visualize what I mean. Oh, and maybe even just work it out. I don't right now. I don't know the answer. Just to be clear, right? So it's not like I'm trying to delay it or anything. I just don't think I know the answer to this. I mean, we're working it out, but I just don't know it at this point. Okay, so I guess the idea here is that okay, so you have, and you have some numbers, but I'm going to draw it as in terms of like a bar graph type thing, right? So you have something like this, right? And then the idea here is that you want to reduce this all to 0 in the minimum number of moves. And I think it makes sense that if we take the min element, right? If we take the min element, and I kind of whatever, right? So like maybe there's more on the right side as well, dot, right? If we take the min element, let's just say this one, and it's in the middle without loss of generality, right? And then we would do it for the entire thing because we can, right? And then what happens? Well, what happens is then now we split it in chunks. I mean, if we have more chunks, let's say we have, then we have more chunks, right? And then what happens? Then now we have a sub-problem, if you will. And then we just have to solve it for this, right? And it doesn't matter if this is the same as this height or whatever, because you already divided by this line. And there's no way to reverse your operations, right? In a sense that like you cannot like go up and then go down or something like that in terms of your increment by subarray. So then that means that we have to do it by this. And then now here we choose the smallest number again, right? And then here, then now you draw in here, you kind of subdivide, but of course it's nothing to the left. And then now you subdivide here by right? And then so forth, right? Okay, so I think that seems reasonable, right? As a strategy, I don't think. Would you call this greedy? Maybe you would call this greedy. I don't know. I think this strategy just works because you can easily, I mean, there are really no other ways to break it down, right? Because you can show that all the other moves are suboptimal, for example. But in a sense, but all those other moves are basically like, like if you don't divide it by say here, then like what are you, like you can't go past this. And like maybe you could say you do something like this instead and then do this afterwards. But that, but you can easily show that this move is more optimal, right? For example. So I think this makes sense. But then now the question is, how do we implement it, right? And I don't mean just like the code wise, even though I do still also means the code wise. But you can think about a worst case in which it looks something like this, right? And then now you remove the min here, maybe find the min, find the min, find the min, find the min, and so forth, right? And that would, of course, if you have to loop through everything to find the min, that would be O of n, and that would be not great, right? And I don't know why that is the ugliest O of n I've ever seen, but right? But O of n for each one, then this is going to be O of n squared, which is not what we want. I know that, and just to be clear, I know that we can do some stuff with, and maybe we have to. I know that you could use segment tree, right? You can use sparse table, LCA, or the other one, or RMQ, sorry. RMQ sparse table, right? Which this is literally range minimum query, right? Though you still have to be a little. No, I mean Does this work? Even if we do this, I mean, technically, yes, it'll give you the minimum value, but then now I worry about tiebreakers, which is, because we can imagine something like, or I mean, I don't know, or rather, maybe not tiebreaker isn't the word, but like for example, if you have something like, I don't know, something like this, then now if you find this is the min, which is easy to do with RMQ, but then now you have to divide this in this many thing, right? Which in this case is fine, but then now you have to look for all these things, right? And that means that if you back to the staircase thing, right? If you know that this is the min, then but then you have to see if there are other cases in which this is also the min. I mean, there are data structures that allow you to kind of do the next thing and maybe bind, I don't know. But that just seems really, really complicated. We'll put this in our back pocket because I feel like this is a very difficult way of doing it, even though it is possible. But I feel like, maybe there's a simpler solution. Let me take a look real quick. At the problem, sorry. I mean, I'm not showing it well. I'm just looking at the problem. Just also make sure that I didn't mess it up. I am trying to think whether there's like a union find solution, right? So let's say we have something like this, right? Then now, is there a way in which, I mean, I have to think through. I don't know whether you can, right? But you have something like, I don't know, something like this, right? And whatever, right? Dot, dot, dot. And then now instead you go to the top where you go, okay, well, you look to the left, you look to the right. Well, we know that this will take one operation, right? And then now you merge these two things together because now whenever you move this thing, you also move this thing, right? And then now, and we keep on going from the highest one because, I don't know, I mean, that just makes sense, right? And then now we find that this is now the highest, so then now this goes to here, which matches here because it takes a look at left, it takes a look at right, it finds here to do the one operation, and then it merges with the right component, right? Same thing here, maybe, right? It goes here, and then maybe it goes here, and then maybe that's fine, right? Is that good? I guess so. So okay, and I think the biggest thing is that then now we don't have to worry about tiebreaker things, right? Because then now, and you don't even need a strict union find per se. You could also use a linked list or like an array linked list. I forget what is the name of it. So there are things you can do. I'm just trying to still, honestly, right now, I'm trying to prove to myself before I'm proving to you that this works. But yeah, give me a second. Let me think. I think this works. I mean, I think algorithmically this works. Hopefully it makes sense. And if it doesn't, I mean, we all make mistakes. But I think this makes sense. And we can have this, we can do it with union find, but I think there is this like idea that I want to play around with arrays, right? With an implicit thing. No, maybe we'll just do union find, I think. Right. All right, let's do it. We might be wrong, but we are adventurous. Because I think I'm okay. So to be clear, I think this is right. and this also shows you the power of what I said earlier, right? Which is, you can build it bottoms up, or whatever you want to call it. Not bottoms up in the sense of like dynamic programming, but just going from like 0, 0, 0, 0, 0 to the target, or the other way around, right? And basically the idea there here, just to be clear, which is why I'm convinced, even though maybe it's not a tough proof, is basically trying to think about invariance. And in invariance is that, well, if you have this number, if you kind of start backwards, change the color real quick, and you go kind of at looking at this one and this the highest, well, there's really no operations that, like there's just no way to do other operations until you reach here. Then now, because you have these two, then you might as well merge them together kind of thing, right? So yeah, implementation may be a little bit tricky, but we'll play around with it. We could also use a linked list. I want to use a linked list, a doubly linked list. Yeah, why not? Right. So then let's use a doubly linked list. Right. Or just node. Doubly linked list node. Something like this, right? And then we'll just do the adjustments around, right? And now we have for x in target, we have maybe head is equal to node of -1. -1 is not possible, right? Yep. And then we have node is equal to a new node of x, right? And then node of left, well, we need a current. So current is equal to head, right? And then, sorry, I'm a little bit rusty. I don't usually do linked lists, so I'm a little bit rusty. It's equal to current, node that right is equal to none, even though I know that we already called it, but yeah, just make it explicit. And then now we have current dot right is equal to node. That's good, right? Current, we assume that current is going to be good. So then, yeah, and then current is equal to current dot right, which is node anyway. Yeah. All right. And we're gonna add a debugger or a visualizer, so just to make sure that we're doing it kind of right. And there's stuff that we're missing for sure, but maybe we could just do for, okay, so current is equal to head again, right? So while current is not none, then we just do current is equal to current dot right, but of course we print current dot value, right? So just to be sure. Okay, I mean we know that, we knew this. Stop asking me to ask Leet your silly AI thing, and I am not finding that necessary. But okay, right? Okay, so this looks good. Just to be clear, I don't know. I got annoyed at AI, but yeah, yeah. Can't AI learn that I don't want it? Okay. Okay, right, and maybe you could also just to be sure, maybe that current dot left. I guess I don't know why I say left and right instead of previous and next. That is the clear notation, but I don't know, right? And this maybe we'll start dot next. Oh man, now I'm confused. All right, let me just convert it to next and previous. Oops. I don't know why. I honestly don't know why I did left right. I mean, I'm looking at it left and right, but I don't know. It doesn't really matter. But I feel like now that I noticed it, I am going to get confused. So right, all right. So yeah, so you see that one. Stop asking me this. What is wrong with you? If you're so smart as an AI, you should know that I don't want it. All right. In any case, yeah, just to make sure that because we know that it loops, right? So we just want to make sure that it goes previously. I don't know. I know this is very basic, but yeah. Okay, so now this is Gucci, right? We also want to put a hash, right, on this so that okay, so you have index this, and then now we also, as we so then we can do lookup of index is equal to current. No, it's node, right? I mean, I think current is node now, but I think this is more specific. And then the other thing we want to do is going from I hope that, I mean, maybe I'm going a little bit fast, but I hope that you see how I'm putting the components together, right? First, I construct the linked list. Second, I put up a lookup thing so that we can look up, well, where and this may not be final, you know, we're iterating, but this is looking up, okay, given an index, give me the node specifically, and we can already have previous and next on it, right? And then the other thing is that we want to be able to go from top to bottom, right? So then now we just also maybe have a I guess in this case it would be a heap, right? No, because when you merge you don't put things back in. You'll be yeah, because when you merge, you don't have to put things back in. It will just be the whatever value is. I think sorted is enough, but yeah, but maybe I'm wrong. We'll see. But maybe it will be. Yeah, just, I don't know. What is a good name for it? Naming things is hard. So yeah. That append. We want to sort by x and then index, right? And then we sort. This sort. Why does this look so weird? Anyway, key is equal to lambda. No, not key. We just want reverse. That's all, right? Stop. Why? Like, what is wrong with this thing? Anyway, okay. So you have 3 at index 2. Okay, so this is what we want. Okay, so then now we can implement what we are hoping to do, right? Which is that okay, so for x index in S, we want to say let's find the node, right? So node is equal to lookup of index, right? And then now let's look to the left and right to see if we can merge and how many steps it would take, right? And also we just have maybe a total count, right? So then now, we also want to take the higher one, right? I think I didn't make that explicit, meaning that, let me bring it back for a second. Right, so let's say we have something like this, or maybe even a new thing, right? But we have something like this. Then if you're here, then you want to merge with the higher one first, right? Before maybe in the future you merge with this later, right? So then now, yeah. So, yeah, okay. I'm trying to think what is the best way to do invariance. And I think here, maybe I'll just do like a negative infinity thing for the head, right? And I might not even need the head anymore, to be honest, but just for thing. But we also want to create a new node where it is also at negative infinity. So that this is like the sentinel last node, right? So that's basically what I want to do. Because if we're trying to take the higher of left and right, then the negative infinity will never hit, because then it will choose the other side. And that's how you pick a sentinel, right? Okay, so if node.left, I guess that's why I did it, but whatever. If node.previous.value is greater than node.next.value, then we take previous, else we take next, right? One thing to know is how just always have to think about tiebreakers. Tiebreakers in this case, A's doesn't matter. Is that true? Yes, yeah. Doesn't matter because the reason is that yeah, it always helps to visualize something, right? But the idea here is that so if you nope. The tiebreaker comes up if you have something like this where they're the same, right? And then now you have to choose between merging the left and merging to the right. You're going to merge this part, and then by merging, and you could do it in code, but it kind of moves this down to here, right? But then now this is one component. This is one component, and then and it doesn't matter which one happens next, either this one or this one, because then now it would either merge to the left or merge to the right, depending on which one is lower there. But in both cases, they'll merge together. I think so. I think I'm just trying to think whether there's a case where you need to do both merges at the same time. I don't think so, because each one of them will get merged with. But maybe I'm wrong. So maybe this is something that, like, if I'm unsure about, it will come out in testing. I'm giving myself a mental note to be like, okay, if you see something wrong, remember to take a look at this part. And sometimes I think during a lot of my videos, I don't make this part explicit. Like I don't articulate it because it just goes in and out of my head so fast. But this is also why sometimes when you see me, like I hit run, it doesn't match the examples, or maybe I even hit submit, I see a wrong answer, and I'm like, oh, it's because of this thing. And then I immediately solve it. It's not because like I'm magical at looking at code. It's because as I'm writing this code, I am thinking about, these kind of cases. So I want to say actively, but sometimes also a little bit sloppily in that, like, if I thought about it, I probably should just write the test case. But sometimes there's just so many things going on in my head that I forget, and then the fail test actually reminds me. It's not that like that's and then and that's when you also see me like going, I knew this. How did I make this mistake? I even thought about this, and that happens a lot too. So. Especially nowadays. I think when I was younger, I was a little bit like, I just care a little bit more when I was younger. Now I don't care as much about these. So, I don't know. In any case, yeah. So then now we take previous and merge. So first, delta is equal to node.value minus node.previous.value. And of course, this should be smaller than this. If not, then we have a lot of issues. But yeah, and then that we added to total, or yeah, and then now we delete the node, right? Delete the current node, so node dot left, node dot previous dot next is equal to node dot next, and then node dot next dot previous is equal to node dot previous dot next. No, that's right. Kind of. I mean, actually, no, I think this is right. I mean, this should be right. But I think it's easier if you just, like, write something like... Because sometimes the way that... I mean, I think this is right regardless, but I think this just makes it more clear because then you don't worry about, like, oh, does this overwrite that or whatever. I think with this one, because you don't have to like move the current count as well, it doesn't really matter. But we're gonna also do this in here, so I'm just gonna take this time to proactively move it out here, right? So then we just take next, so delta, yeah, because the idea here is that when we delete this node, then now it counts as merging with one of them, right? Like if you kind of, this is a little bit, I don't know if it's hacky or whatever, but basically if you kind of rethink about this visualization, right? If we just, like if you think about this and we move this to merge, is this any different from just when we have this, we move this, and then this leading to, just this, right? No. So that's basically the observation there. It's a little bit, I mean, it's an implementation thing, but we'll see, right? And then at the end, we just return total. Is that true? No, because I think this goes into negative infinity, but I'm going to run it just because I just want to see if it crashes anything else by accident, like some typo or something. But I suspect that the last element would go, because when you only have one element left, then the left is negative infinity and the right is negative infinity, and that gives you a huge number. Yep. See? So I mean, it's important to know that you're working on things incrementally and expect the right things from your things. So I think this is fine, right? And nothing, because this is now an error on the return value, which means that everything before that is kind of okay. Maybe not, but kind of okay, right? Okay, so then now we have to do something about the last value, because we have to do two things, right? I guess maybe not. Maybe we just have to change them to 0. Maybe I'm wrong on this, because 0 is not a possible value, and then now you're reducing the last segment to 0. So maybe that is actually better, and maybe that solves it by itself. No. I just chose a huge value because I didn't want to think about it at that point. But apparently when we choose it to 0, this looks better, right, already. You just have to give it a little bit of a thought, which at that time I wasn't quite sure that I want to spend the brain cycles on, right? But yeah, but as soon as as I thought about it, well, I have two problems. One is that, okay, the last thing we have to reduce it to 0, then why not combine both, right? Anyway, all right, so with all that said, let's give a quick submit. We could still ask Leetcode for some reason, or Leet, if you will. But no, we don't need your help. Stop asking. Stop trying to. Is there a way to turn this off? Like, why is it asking me all the time? Like, I don't want Leet. It just kind of keeps popping up and getting in my way. It's almost like a pop-up ad, except for it shows up like 6 times. Why does it need to show up 6 times? Oh, it didn't show up that time though. I actually don't know when it shows up. I guess maybe I don't know. Anyway, so what's the complexity here, right? We do have a sort, so that is going to be the dominating thing, right? I mean, you look at everything else, it's going to be linear time, linear space, in total, right? For example, the lookup thing has all of one time and space per node. Also, each node has all of one time and space, right? And yeah, and everything is all one except for the sorting, which is n log n, and that's it, right? This is n log n time, all of n space. Can I do better in space? I don't know. I don't know. I am curious what I did last time though, because this is kind of tricky, and of course I have to ask Leet again. But wow. Well, apparently there is a cleaner way. I mean, it's still linear space, but I really did not think about this in terms of monostacks. I mean, I guess it still uses the invariant that we used here with respect to, if it goes down, then you know that it creates like a, because the idea, I guess, from that stack, well, past Larry from 5 years ago is smarter than me still. All right, well, but the idea is still the same thing of like, okay, let's say you have a lump, maybe make it a little more staircase. The idea here is that this is going to be monotonically increasing like a staircase, right? But as soon as you go down, that means that there's this thing to chop off, right? And then you kind of just remove it that way. So actually, I mean, it's still also the same merging idea that we have, except for that now we're able to do it on a stack kind of way, because we're just seeing that whether we're merging to the left. Because, okay, I see. Because the idea here is that, because the way that we do the merging here on the n log n solution is that we look at this and we go, okay, should we merge to the left and merge to the right? But then in the stack solution, it's just going, okay, we always merge to the left. And then we only check whether it merges to the left, right? Because if it doesn't merge to the left, let's say you have a reverse staircase thing, then now, you kind of merge this one to the left in that way, right? Because then now you chop it off that way. So you always merge, except for when you go up, because then now you know that maybe this area can overlap with this area. All right, I mean, I think it's a very similar idea, but you can see that the implementation and the idea and the overall idea are very different. That's crazy. Maybe I gotta watch that video, honestly. But somehow this is much faster. But I think that's just from 5 years of like Leetcode upgrading their servers or something. Yeah. All right. Well, if you're curious, you could watch that video as well. But that's all I have for today. Let me know what you think. Thanks for watching. Stay good. Stay healthy to your mental health. I'll see y'all later and take care. Bye bye.